So then floating point support or microcontroller. See, representing a floating point number or real number is a little bit tricky in computer. That means they require nearly 32 bits to represent real numbers minimum. That is called as IEEE 32-bit floating point numbers. Have you heard about it before?
No answer. Standard I haven't heard, but I
As
heard from you.
actually, we have UDS standard for diagnostic right now. Also, we say that CAN itself is standard. Right. What is standard, first of all?
A
Any
group of
idea?
people will design what to do and what not to do and how to be performed.
Okay, what they decide? They set of rules,
Yeah.
right, to do certain things. Once they agree, they all will follow the same. That is what the standard is. So when people want to represent a real number, which has a whole part as well as a fractional part, they follow a standard called IEEE 32-bit floating point format. So any real number require 32 bits as per that standard, right? So you can represent 0.000005, which is very least number right now. You represent that, you require 32 bits. 99999.9999999, maybe you can have 109 also. To represent that also you require 32 bits. So how they are doing it? There is a standard. They used to call it as Mantissa, and let me tell you that standard. There is a great explanation about that, because you should know the knowledge of Mantissa, and then we have another word. So most of the floating point controller or microprocessor, when you look at controller or microprocessor, they are in two types. Fixed point. While they mention the controller microprocessor, they will say fixed point microcontroller and then floating point microcontroller. What is mean by floating point microcontroller? See, if something is fixed point microcontroller, do you mean that we cannot represent a real number at all, floating point number at all in that controller? Do you believe like that?
No answer.
Actually, even in the fixed point microcontroller, you can represent real numbers. You have to follow a method that I am going to explain. Maybe probably they can use the same 32-bit IEEE floating point representation. To represent any number, they require 32 bits. See here, they have sign bit, sign, exponent, and mantissa. This is the concept that they are following, right? See, if you look at these bits, they are binary zeros and ones. The totally, you may find nearly, I think initially it was 32-bit. I think this is very latest. When I was working in industry for structure of 32-bit IEEE float, here it is. Sign bit, the most significant bit of 0, positive 1 or 0 for positive and 1 for negative. Exponent, this field stores the
Answer. Are you
exponent.
sharing the screen?
Oh, sorry. Even it is a fixed bit processor, microcontroller, they have to follow this format. At end of the day, if you look at these bits, there is no dot, there is no real part and fractional part like that. It's series of zeros and ones. How they represent this, using this, how they represent a floating point number, that is explained here. The one bit is used as signed bit, 0 for positive, 1 for negative. Then the exponent can have the value of 8 bit, I believe, 8 bits, minus 126 to plus 127. And then the mantissa significant, which is mean 23 bits they are using. 23 plus 8, 31, this one bit, totally 32 bits. Right, they follow this method, sign, exponent, mantissa format. Using that only they will represent. The problem with this floating point standard is to implement this in your microcontroller or microprocessor. If it is a fixed bit microprocessor, fixed bit means it is not supporting floating point number by default. There is only fixed whole number support is available in this microcontroller. In that case, you have to write a very lengthy programs to support this standard, because in a microcontroller, when we write for embedded program for automotive unit, it doesn't have a layer called diag layer right now. It doesn't have a layer called UDS. Do you agree? It's just a microcontroller program that can drive some port and make them pin to on. It can store some, it can digitize something using ADC. It can communicate the information from this microcontroller to outside world using some communication standard. These are the things that a microcontroller can do. But along with, when we want to support a diagnostic activity for a embedded module or a car module, we write programs right now. There is, if you work in development, you will have a separate package, a set of files for UDS. You have to compile that along with your applications. Do you agree on that or not? Yes or no?
Yes, sir.
Like that, when a microcontroller or microprocessor want to support floating point arithmetic, they have to write libraries. Floating point library will be there. Using that only you can do real calculation. That means floating point calculation. That is more time consuming, because to do that there is to be a lot of libraries. For addition, they have a library. How to add a IEEE 32-bit point numbers, two numbers, how to subtract it, divide it, square root. For everything they have a library. These libraries are not just like that. They are, for that we have to write a program, microcontroller program. Right. That is very lengthy, so that performing IEEE standard based floating point calculations require more machine cycle. It consumes more time, so your process will be slow. That's why the people come up with modern controller with floating point support. That means you no need to write any library or no need to write any program to do a floating point arithmetic, that is already implemented in the logic. That means microcontroller itself will be like that. Always it will use IEEE 32-bit point to represent a number. All numbers that you use in that are IEEE floating point numbers, real numbers only. There is no fixed floating point, something like that. So those microcontrollers will be little bit pricey, and this will be used in the applications like digital signal processing, those sort of signal analysis, and then these audio related features, navigation related speech features, there they are used. But for these microcontroller, for we are developing a microcontroller for an automotive applications, means the fixed point itself enough. Fixed point microcontroller itself enough. So now the challenge come in front of us. If we want to do a floating point number, how we will do? There is a method. The method is very straightforward that I believe you may aware of that one. For example, I want to represent, we are using it in CAN bus data we are transmitting, right? In that we are using that all numbers. There is no floating point numbers encoded in CAN signals. All of them are zeros and ones. So for example, I want to represent 2.55. This is a number I want to represent. If I want to represent this using IEEE 32-bit format, I have to follow a standard in that this 2.55 will be converted into 32 bits. That is very costly. What I can do now, I can multiply this number with 100. If I multiply this with 100, what is the output? 255. Yes, na? Agree? When we multiply that number by 100, we get 255. Do you agree or not? 255. 255 is a whole number. What I will do, I will just encode 255 can be encoded as a data in CAN packet. 1 byte is required because 8-bit it is totally. So I encode 255 in my packet and will transmit from one node to another node. So the other node is receiving this as 255, right? There we have something called as resolution. The receiving node will not process the data as such. 255 is the data received in the bus. When they are encoding it into zeros and ones, they encoded 255 only in the data bits. But on the receiving end, they will receive this data and will multiply with the resolution 0.01, no, 0.001. So when we do like that, automatically, so if I multiply this with, I am getting 2.5. Agree? Yes or no? Come on. See, the source node has the value 255, 2.55. Now, when we want to use it in calculations or when we transmit them in the bus, because this is fixed point processor or microcontroller, there we cannot perform this 32-bit arithmetic. In that case, we multiply that number by 100 and we convert that as a whole number. And then we use that in our all calculation, everything. Finally, after we do all calculation, we will get a result. No, that result will be multiplied by the resolution. This is 0.01. Actually, we are making a two, that means two digits resolution we create. So when we do like that, again on the receiving end, we get 2.5. This is the method used in microcontroller. Most of the microprocessor, those are fixed point to do a basic simple real number calculations. But when it is something more complex one, they are doing a filtering convolution operation or FFT or DFT, like that we have different digital signal processing calculations or scientific calculation. In those times, this arithmetic will not work. When we do the sort of multiplication and application of resolution will result lot of error, so their accuracy will be destroyed. In that case only they will go for this method. Do you understand now what are the two methods used in microcontroller programming to handle real numbers? Come on,
Sorry.
what you understood?
So they will be having some set of algorithms to decode. So for this, we will
Okay.
be having small arithmetic things like computation with 100 and other end decoding the algorithm. For the
Actually, this.
accurate things,
Yeah, yeah. Go on, go on.
to get the accurate value, we will be using that fixed point resolution.
Hmm. So, this when you need your real calculation is moreover mostly in real numbers and you need a real accuracy, then go for this. There are controllers, they are called as floating point controllers, floating point microprocessor, if it is a digital signal processor. There are other way around. In that, we follow this method. Actually, what I have multiplied is 1 by 100. I multiplied the source side, I multiplied by 100. On the receiving side, I divided by 100. That's all. To get the result, what I want to. At the end of the day, I am able to transmit that without any problem in the channel. Maybe in the real bus or in the CAN bus or LIN bus, I'm able to transmit the data without losing my content. So I don't have any challenge to use IEEE 32-bit point numbers to represent that one. Clear? So these are the two ways to handle a real numbers that should be known to you. So if you don't know and try to program whether that controller is supporting a floating point or not, right? If they are doing in the fixed point controller also, they have a libraries for floating points to do these things. To do these sort of additions and multiplication, they have written object programs, libraries, just to include them, and then you do the calculations. When you do the calculation in backend, they will convert your expressions into the lengthier expressions, which involves a lot of steps to perform an addition or multiplication or whatever it is. Finally, they will come up with an object code, right? That will be little bit lengthy. So this floating point arithmetic will be implemented in software. That is possible to implement, but it will consume machine cycle and it is very lengthy. You will get a very lengthy source object code. You require a more memory to flash them. That is the challenge that we have when we do these floating point arithmetic in fixed point processor. There are certain processor microcontroller, they by default support floating point arithmetic. There you don't require these libraries. Just you do calculations in backend, the microcontroller itself will do those operations. You got the point? Come on.
Question, sir.
Integer representation of a real number. So 32-bit floating point number. There are two type of floating point numbers are there. How to use them?